All right, we're going to use implicit differentiation to solve because we got both x and y in our equation here. So again, first step, find the derivative of both sides. And anytime there's a y, include dy dx. So this first one here, we got on the left side, we got sine of the function x plus y. Well, this has a function in another function. We know from previous lessons then that this is going to require us to do chain rule. Okay, on the other side, we also have two functions. This isn't a function in a function. These two functions are being multiplied. So this side's going to require us to do product rule. So you still have those rules we've done before of product rule, quotient rule, chain rule that you may need to apply when doing implicit. So let's start with the left side here. If we're going to do that derivative, start with the outside part. So derivative of sine is cosine. When we do chain rule, we leave the inside alone. But now we got to do times the derivative of the inside. So what is the derivative of the inside? Well, derivative of x is 1. Derivative of y is also 1, but because it's y, we want to include our derivative here, dy dx. All right, so now let's move to the other side, product rule. We know how to do product rule. We got the first function times derivative of the second, which derivative of cosine is negative sine, plus, now we switch them around. So now we got cosine times derivative of y squared, the other function. Well, derivative of y squared is going to be 2y, but again, it's a y one, so you got to include derivative dy dx. All right, so now our goal is to solve for dy dx. Let's start with that left side there. So it appears we got two things inside here. Looks like we're going to need to distribute on that side. So let's start by distributing. Cosine of all this times 1 is just going to be cosine x plus y. Plus, now if we multiply that to the other one, we're also multiplying it to 1, but it has that derivative next to it. So it'd be cosine x plus y dy dx. Okay, on our right side, just not really much solving to do, but let's write this a little nicer. I'm going to write that negative in front, so negative y squared sine x. And here I'm going to put the polynomial term first, so 2y cosine x dy dx. Okay, so now we want to solve for the derivative, but what's new about this one is we have derivative on both sides. So going back to the rules that or the guidelines that we had, steps we had to solve this, when you have more than one dy dx, you want to collect those terms on one side of the function or the equation, and then we're going to factor out that derivative. So that's going to be necessary on this problem. So you got to pick one side. It doesn't really matter which side you move it to. I'm going to choose to minus this one over. So I'm going to subtract this one to the other side. In doing that, I also don't want any terms that don't have the derivative over on that right side. So that means this one, since it doesn't have a derivative, I'm going to add that one over to the left side. So I'm going to write out what we have now. Cosine x plus y, no derivative on that one, plus, because I added this other term over here, this one, because that doesn't have a derivative either. On my right side now, I have 2y cosine x dy dx. And I also subtracted this other term that had the derivative over here. Okay, so now we're closer to our answer. Because we have both of these have the derivative on this side, we're going to factor it out as our next step. So if we factor it out, now I got all this stuff. Times our derivative equal to the stuff over here. And my last step now can be to divide and get our answer. So I can divide by all the stuff in the parentheses there to get our final answer. So dy dx, or our derivative, is equal to cosine of x plus y squared sine x. All this stuff on the left side divided by all this stuff, and that would be our answer. So this ends up being our derivative. You can see when you start having to involve some of those rules, your answers do get a little more complicated sometimes. All right, let's have you try this next one. So see if you can use implicit differentiation to solve. The one part you got to be a little bit careful on right here, looks like we got two functions being multiplied. That's going to involve product rule here. So make sure you include that when doing that. So pause the video, try it out, and then see how you did. All right, let's see how you did when doing this one. You had to take derivative of everything. So first one was 4x right here. Second, the next thing, this is our product rule. So you got first function times derivative of y, which would just be 1 dy dx. Product rule always has plus. Derivative, now switching around, would be y times derivative of x, which is 1. So that's our part with product rule. Make sure you did have this other dy dx in here when taking derivative of this one, because it's derivative of y. Make sure you had that dy dx, and then also make sure you had 0 over here, not 7. Derivative of a constant would be 0. So now you want to keep the dy dx terms here, and then I minus the other ones to the other side, factor out the derivative, divide, and you got your answer. So this would be the derivative right here. One other thing you might see, especially when checking answers, like on the top, how both of those are negative, sometimes they'll factor out that negative for the final answer. So it looks something like this. And then instead of having like a parentheses around that, they'll take the negative sign and just move it out in front of the fraction. So it's going to be negative no matter what. And then because now the negative's out there, you don't need the parentheses anymore. So this might be another way, if you were checking answer, that you would see this answer written as that it'd be the opposite of all this stuff that we have shown there.